Well, I must admit this PowerPoint would have been a lot more fun if we were in the room together, because I've got a lot of matching places where it's like, hey kids, do you think this equation goes with picture A, B, C, or D? And I don't know, we could have taken turns answering, or we could have tried to simultaneously answer them, or whatever. But so here we go. It's time to kind of wrap up. We're nearing the end of the unit. We have studied each of the 4 conic sections, and so now we got to see, well, if we mix them all up, can we figure them out? And I don't know, that face is maybe a little disturbing, so let's move on. And it seemed like a good idea when I started working on it. Okay, so again, this I think would have been fun in class. Is, hey, what do you think number 1 is? We could have taken turns answering, but instead we are here in this crazy virtual world. If I start going too fast, remember, you can pause the video. Number 1. What should number 1 go with? Well, only the x is squared. It must be a parabola. Notice that the parabola's vertex is 5 units below the origin. That's what that -5 is telling us. Number 2, I wonder what shape that has to be. What conic section? Well, the x squared and the y squared, both variables are squared. Neither one has a coefficient. It's got to be a circle. The 7 squared tells me the radius has to be 7. Sure enough, B looks like a circle with a radius of 7. Number 3, x is squared, y is squared, but look at that, they got different coefficients, right? X squared is being divided by 64, y squared is being divided by 16. So that's kind of like x squared has a coefficient of 1 over 64, y squared has a coefficient of 1 over 16. Those don't match. So if they're both squared and everything's positive, but they don't have the same coefficient, it's an ellipse, right? A circle has been stretched out. Now again, let's actually figure out number 4. I know the only letter we've not used is A, but let's actually figure this out instead of just picking A. X is squared, y is squared. Ooh, but one of them has a subtraction symbol, right? It's not x squared plus y squared, it's x squared minus y squared. So if they're both squared, but one of them has a subtraction symbol, or if you want to think of it as being negative, it's got to be the hyperbola. So sure enough, A will have to go with number 4 because it's the only hyperbola. Okay, more fun. We did A, B, C, and D. Now let's do E, F, G, and H. Ooh, and these equations look a little bit more interesting. So again, number 5. Which shape does number 5 have to be? Well, only the x is getting squared. It must be a parabola. Now if I look at the equation, the x minus 4, I got to think opposite and say, okay, positive 4. I see the plus 1, I say, okay, positive 1. So is 4, 1 the vertex? Yeah, it looks like that parabola has a vertex of 4, 1. So it's a parabola. The vertex is in the correct place. Let's go with H. Number 6. X and y are both squared. Neither one has a coefficient, or I should say the coefficient's 1. So they have the same coefficient. Radius has to be 10. The center of the circle needs to be at 3, -6. Yep, circle F looks like it's going to fit the bill quite fine. Right, it looks like that circle could very well be centered at 3, -6. Looks like the radius is 10, right, because it looks like the diameter is about 20. It should be exactly 20, but, you know, I'm just kind of glancing at the picture and making a best guess. Number 7. Well, X and Y are both getting squared, but we've got different coefficients, right? The X has a 1/9 as a coefficient. The Y has a 1/4 as a coefficient. So it's got to be an ellipse. The ellipse needs to be centered at -5, -1. E certainly looks like an ellipse that'd be centered at -5, -1. Number 8. Again, I know there's only one shape we've not used yet, but let's figure it out for real. Oh my goodness, look at that. There's a negative on the y squared. We've got a positive x squared, but there's a subtraction symbol in front of the y squared. One of them's negative. It's got to be a hyperbola. The x -7 tells me the x coordinate of the center should be 7. The y -2 tells me the y coordinate of the center should be a 2. It should be centered at 7, 2. And if I look at that hyperbola and try to figure out, okay, what's halfway between those two vertices? Well, it looks like 7, 2 would be correct. So that has to be the last of our matches. Now, for the purpose of a worksheet, don't feel compelled to print the entire thing out on paper. If there's a matching section, I really don't need to have you spend that much money in ink printing out the diagrams, the pictures. So for that part, you might just want to say, hey, I'm gonna open up the worksheet online, take a look at the worksheet online, but no reason to print that part out. Classify each conic. So what do you think number 9 has to be? X is squared, Y is squared, they're both positive, but they've got different coefficients. It has to be an ellipse. Number 10, the X is squared, the Y is squared. They both have a coefficient of 1. That's got to be a circle. Number 11, both the X and the Y are squared. Uh-oh, one of them's negative. I see a -7y squared. So that must be a hyperbola. Number 12, again, no fair using the last answer. You got to figure it out. Hey, there's an x squared, but the y is not squared. It's got to be a parabola. Now again, when you get to a worksheet, if you see this type of question, you know, if printing out is not a big concern and you want to print out the worksheet, that's fine. If you'd rather just, you know, type answers online, or if you just want to copy the question on notebook paper and use pencil and paper and then just take a photograph of the pencil and paper, whatever works for you. I'm very amenable. Well, for the vertex, well, when I see the x -9, I gotta think +9. And then on the outside, I see the +13. I just keep it as a +13. Now, from that vertex, we have to move to locate the focus and the directrix. Since it's x squared, I know that the focus will be directly above the vertex, so I'm not going to move left or right. Right? Y equals x squared, kind of visualize, we've got a right side up parabola. So how far straight up from the vertex do I have to go? Remember our good old friend, 1 over 4 times p? And in this case, I see a 1 over 28, so I wonder what p has to be. 4 times p has to be 28. Yep. So I have to move 7 units. So 13 plus 7, ta-da, 20. Now, if the focus is 7 units straight up from the vertex, the directrix has to be 7 units straight down. So 13 subtract 7 is going to give me 6. Remember, the focus is a point, so I need an x, comma, y inside parentheses. The directrix, though, is a line, so I need the equation of a line. In this case, y equals 6. Axis of symmetry, well, it's got to go through the vertex on the focus. It looks like x is stuck at 9. Again, the axis of symmetry is a line, so I need the equation of a line. Oh boy, circle. Can you find the center and the radius? I see a plus 7, so I've got to think negative 7. I see minus 4, so I got to think positive 4. Of course, the square root of 36 is 6. So the radius is going to be 6, right? I can either try to think of that as I'm looking at 6 squared to be 36, or I could just say, hey, no, I got to take the square root of 36. It comes out as 6. I mean, whatever works best for your brain. You might even have a different way of thinking about it that works for you, which is fine. Oh my goodness, we have an ellipse. Okay, it looks like it would be centered at the origin, right? So it would be centered at 0, 0. So we just got to figure out how far to move in each direction. Okay, now the larger number is going to be 225, right? 225 is larger than 81. So the vertices will go with x, right? Because the 225 is underneath the x squared. And so we will move, wow, 15 units. 15 units in the x direction each way. So the co-vertices, those will move in the direction of y. And of course, the square root of 81 today would be 9. Check back tomorrow. It might still be 9 tomorrow. You'll have to double check on that, though. So the co-vertices, 0, 9, 0, negative 9. The foci have to agree with the vertices. So if the vertices went left and right, the foci have to go left and right. Now again, in the original equation, I see a plus sign. So when I'm trying to figure out the value for the foci, I actually end up subtracting. Square root of 144. Oh, how lucky can we get? It comes out to be exactly 12. So the foci, 12, 0, negative 12, 0. Eccentricity. Distance to the foci divided by distance to the vertices. Right, so the eccentricity, 12 over 15. And if I wanted to, I could reduce it as a fraction. Although quite often with eccentricity, for whatever reason, mathematicians like to do decimals. Usually rounded to 2 decimal places, but in this case, it comes out to be exactly 0.8. So you could have reduced it to be 4/5 or 0.8. Let me see, we've done a parabola, a circle, an ellipse. We got to do a hyperbola. So let's get a hyperbola up here. Vertices and foci. Now the positive number is always the larger number. So I don't have to worry about the fact that 225 is larger than 64. It's like, hey, the 225 is positive, the 64 is negative, so of course the positive number will be bigger. Then square root of 225, as we just saw previously, square root of 225 has got to be 15. So those are our vertices. For the foci, again, the original equation has subtraction in the middle. So when I try to figure out the location of the foci, I will actually add. Might need a scramble for a calculator on this one. Not too many of us have this memorized, and very few of us are going to be able to do this in our head. 17. Right, now if you look in some math books, they'll talk about covertices on a hyperbola. But a lot of math books don't venture there. I never learned that way. I've never taught that way. It's like, hey, the vertices and the foci, because those curves have to wrap around the foci going through the vertices. And then, of course, the covertices, all we really use those for is figure out how to draw the rectangles we make the asymptotes. But if I'm just asking for, different pieces, I'm not going to ask for the asymptotes, right? I'll look at the foci and the vertices for the hyperbola. And then if we want to graph a conic section, well, we just did this ellipse a moment ago, and so I just copied the answers we had for that ellipse. Right, we found the vertices, the covertices, the foci. And so I can put those on my graph paper. And then again, if you have to draw this by hand, I'm not looking for artistic perfection, right? If I try to draw it by hand, it looks like a really lopsided egg, so don't worry about it. And then I'm reusing the information from the hyperbola, although I don't think, since we're doing this from remote access, I don't think I'm going to actually have you do the graphing today. I think if we're in the classroom, I would have photocopied the graphs for you, but I think I'm going to knock those off the worksheet. Don't need to have you printing out graphs. And it's kind of awkward if you have to try to use your own notebook paper for graphing. But anyway, those would be the vertices and foci. And then if I look underneath the y squared, I see a 64. The square root of 64 would be 8. And so I could certainly figure out, okay, there's my rectangle. And if I've got my rectangle, I know the diagonals are going to be my asymptotes. And then I think I graphed this, and I think the curve gets way too close to the asymptote very quickly. I'm sure if I went to a website such as Desmos and graphed this on Desmos, that I would find that it wouldn't approach the asymptote that quickly. But I did this with a drawing tool and tried to make it look like a hyperbola, but I think I'm way too flattened out the vertices, and I think I hugged those asymptotes way too quickly. But oh well, right? Like I said, we're not going for artistic perfection. So worksheet today, which is going to kind of take us down memory lane. I'm going to have it available both as a Word document and as a PDF. I've had some students tell me that they prefer to work one way, other students tell me they work the other. I've also had some students tell me that they have difficulty manipulating one or the other, right? We're all using different brand computers with different processors. We've got different internet speeds and everything else. So this is certainly not a one size fits all. And so, you know, whatever method works best for you is the method that you should use. Again, please send me an email if you have any questions. For the most part, with both my calculus and pre-calculus classes, I've just been getting correct answers via email. Right? I've had some of my Algebra 2 students ask questions. I've had some of my geometry students ask questions. But with calculus and pre-calculus, either I'm just making this way too easy, or you folks are just really, really good mathematicians.